Check. Okay, let's see, is the beat going through? Oh, that's the wrong screen. I need to look at this. Now it should be going through. Don't know why that turns off every time. Okay. So where did we leave off? We just need to connect the UI to the audio processing. So let's see. Let's build the standalone and see what this looks like again. Yeah, so we got our dial and our phase button. Very cool. And we can make it larger if we want. So that's whatever. So how do we actually attach this to the audio processor? Well, Juice has something called a audio parameter attachment, or a slider attachment, button attachment, combo box attachment. Let's pull it up on the docs. And I'll just search attach. Mint. I'll just go to slider. And look, slider attachment. So let's go to slider. And if you scroll down, it's going to be below the member functions, I think. Oh wait, was I wrong? Did I skip it? I thought attachment would be in here. That's weird. But if you search slider, you'll see slider attachment. Oh, it's an audio processor value tree state. Okay. So let's go into audio processor value tree state. That makes sense. And it'll show you the different attachments that you can use. So we've got button attachment, combo box attachment, and slider attachment. So these are all the things that are inside of audio processor value tree state. So we can use these attachments to attach the audio processor value tree state to the UI. So these are the different attachments you can use. And that pretty much covers everything that you would need to use. Yeah, I guess that's why there's not one for every single object. So let's check out how to use this slider attachment. Okay, so it takes in your tree state, which, if you remember, we have this thing called tree state, and that's what we're using to add all of our parameters to. So whenever we use a parameter, if you remember, we use this tree state.getRaw parameter. So we're going to use that tree state. We'll pass that into the attachment. the string, the parameter ID, which remember the parameter ID is the lowercase string that we gave it. So this is the ID and this is the name. And then the slider, so whatever you're attaching it to. And you can see it takes it in by reference. So how do we actually do this? It's not too difficult. We go into the editor and we have to make some of these attachments, and we're actually going to make unique pointers. So we can say std for standard template library. That's where the unique pointer lives. Unique pointer. Yep. And this is a slider attachment. No. Audio processor value tree state. Slider attachment. Okay, so I'll just call this what's the, oh, it's called dial, so I'll just say dial attachment. Okay, so now it's a unique pointer, so we actually need to make the unique pointer. So we can go to wherever the dial is, somewhere at the top. And oh, this actually matters. I forget which one it is. You need to put it either before or after set range, and it actually makes a difference. So I think it goes before, because I think I put all of my attachments at the top. So I would say dial attachment is equal to, and then it's a unique pointer. So now we need to make the unique pointer. Make unique, and it is the same juice audio processor value tree state, and then it's a slider attachment. And then the arguments. Okay, so we need the tree state, right? Yeah, so the tree state to use, but that is in the plugin processor and it's public, so we should be able to get it. But how do we actually do that? And to access the plugin processor, we actually use this reference right here, audio processor, which it sets up for us. So you can see this is the class name for the project, so the plugin processor. Yeah, so that's the audio processor, so you can pass that in. And where is it at? Right here. Okay, so audio processor tree state. It wants the ID, which for that one I think it was gain, and then it wants whatever the component we're attaching it to, so the slider we're attaching it to. And we'll give it dial. And I think that works. It should be fine. And then we could do the same thing for the button. So let's just copy and paste this. And I'll say button attachment instead. Button. Okay. And we'll copy and paste this. And let me go look at those names again. Gain and phase. Okay, good. And then here's the button. I'll just also put it at the top. Button attachment. Button. Phase. And button attachment. That should work. Okay. And then how can we make sure that this works? Well, we need to turn off the generic editor, because remember that was automatically creating a UI for us. So if we turn that off, we should be able to see our actual UI, which I think is the case right now. Yes, it is. So now, since they are attached and we have our listeners, the plugin should work just the way it was with the generic UI. So does anything need to be No, I guess we're good. We're making sure that in prepare to play, our parameter is always updated. So phase and raw gain are always what they're supposed to be. That should be fine. Okay, let's see. Let's change it back to AU and build. Oh, the matching constructor. Oh, I bet I messed up. Am I missing like an asterisk somewhere? Let's see. Recent. Let's open up the LV50A. File. Wait. Where are the attachments? Constructor? Yeah, okay, so audio processor, tree state. Oh, it's no ampersand. Oh yeah, it asks for a reference. Yeah, okay, so it asks for a reference into it. So that built pretty cool. Okay, so here is, let's see, turn off the beat for a second. So let's put our plugin on. Where is it? Viator DSP, what did I call it? Stream Juice Intro. So here it is. Oh, look at that, it's working. It's working with the attachment. Let's make sure phase works. Back at Unity Gain. Oh, phase isn't working. Oh, wait. That's why. There are two instances of the plugin. There we go. That works. So that's pretty easy, right? We've got our UI attached to the audio, and that's it. The plugin is completely done. It saves the state. You can automate the parameters, all that good stuff. So yeah. Let's see. Is that going to be enough? Let's see. So okay, let's recap exactly what we did. We got rid of the generic editor, right? So now it's our UI that we actually built in the plugin editor, but we need a way for these UI components to attach and connect to the audio processing. So Juice has something called dial, button, and combo box attachment. And it is part of the audio processor value tree state, which of course we're using to create the automatable parameters, the audio parameters in our plugin. So all we have to do is create an instance of those attachments, one for each of your UI components. Just make a unique pointer and declare it like this in the header. And then you go into the editor where the code to initialize your UI components is. And it'll just say the attachment is equal to now make unique. And it's the audio processor value tree state slider attachment. You pass in the tree state to use, which, you know, usually is going to be, you're only going to have one, so you'll use your tree state. The ID for the parameter, and remember the ID is this first string, so the one that I usually leave as a lowercase, and then this is the name instead of the ID. And then we pass in what component we want to attach it to. Now, I'm pretty sure if you attach it to something that's not a dial, so let's like put button in the slider one. And let's put dial right here. I assume that it'll give you an error, but let's see. Yeah, it gave you some error. So it'll just say no matching constructor for initialization. And that's because the constructor is asking for a slider inside of slider attachment. So that's pretty easy. And yeah, that's basically it. That's how you connect the UI to the audio processing. And now our plugin is completely done because we can automate it. We can save and recall the parameters. We can package it, everything you need. So now, or what should I say? Yeah, I guess now we can move on to something else. So let's maybe, what would be a good next step? Is anybody in the chat? No. Doesn't look like anybody's in chat, so I wish somebody could suggest something. Turn the beat back on. Oh, let me at least commit and push. And is the build okay now? Did I press build? Okay, VTOR DSP juice intro. Okay, so added UI attachment to audio processor. Okay, so one thing I could do is start showing you how to use, what would be better? Oh, we could use the DSP module. Okay, let's do that. Okay, so cool. We already have the audio block. So let me show you how to use the Juice DSP module. And since this is already a volume gain plugin, Juice has a gain DSP module, so we'll be able to use that. Let me just comment out the DSP block and we'll leave the audio block. We'll need that. I'll show you real quick. And let's just go to the documentation and get started with this. So I was already on the documentation. Let's go to DSP. Okay, so there's actually a bunch of stuff. You got bias, chorus, compressor, convolution, FFT, filter design, gain, ladder filter, limiter, LR filters, noise gate, oversampling, all kinds of cool stuff. So let's take gain as an example. And let's see, the one thing to always check is the constructor to see how you can call it. And since nothing is in the parentheses, we can basically just do this. We can go into the plugin processor and we'll create an instance of a gain module. So we'll say juice. It's in the DSP namespace and it's called gain. And it takes in a template type name. So this is how all of the Juice DSP modules are. They take in a type. So you can type in either like a float or a double and it will just, you know, use the generic type or you can type in float or double and it will use that throughout the entire instance. And I usually just say float and I'll call it gain module. Now each DSP module, let's make sure that, okay, it's good. All right, cool. So each DSP module has a set of functions. Normally they're gonna have at least a prepare, a reset, and a process method. So you always have to call prepare, and then you always have to call process. Process you'll actually call in the process block. Prepare you'll call in the prepare method. And then it's usually going to have some kind of other methods that are related to the parameters. So like for gain, it's set gain linear or decibels, set the ramp duration. Stuff like filters will have like set cutoff, set hue, set resonance, you know, stuff like that. So let's look at prepare. So we can see that prepare takes in a process spec. So let's go to process spec, and process spec has sample rate, maximum block size, and num channels. So let me show you how we deal with that. We can go in the prepare method. I'm going to put this at the top. And let me switch over here. Okay, so we are creating a process spec, and since we only need it in prepare to play, and that's because we only need process spec when we call prepare, and you're always going to call prepare in the prepare to play function. So you can just make it local to prepare to play like this. So we're making an instance of process spec, and then we are passing it all of the info that is on this page right here. Oh, I went back. Let's see. Juice DSP class. And we go back to, okay, just go to bias and process spec. Okay, so sample rate, maximum block size, and num samples. And the convenient thing is that prepare to play takes in the project sample rate and samples per block. So we're just setting spec.sample rate, which is this sample rate right here. Spec.maximum block size to the samples per block, and then num channels is also easy to get with get total number input channels. So we have our spec, and this is kind of initializing it to what it needs to be. So we can take that gain module and we can say prepare, and it'll ask for that process spec, and you can just pass it spec, which is this process spec right here. We can also initialize anything that we're not gonna like change. So like, for example, at least the way I want to use it, I'm not gonna change the set ramp duration seconds. This is like smoothing of the value changes. So I'm just gonna set that to a value like 20 milliseconds and just keep it like that. So since I'm not gonna change it, I'm just gonna put it here and prepare to play, and I'll say game module dot set ramp duration seconds, and I'll give it 0.02 for 20 milliseconds, just so that if we move the dial really quickly, there won't be any like pops and clicks. What's up, code crackers? Thanks for the follow. Another thing that we should do is initialize anything that is a parameter that's going to link up to the module. So for example, we have this raw gain, which is, you know, tree state.getRaw parameter value. And we also have a set gain. So it's a good idea to just go ahead and call this in prepare to play to make sure that it's set. So we could say, I'll actually just move this right here. We're getting raw gain right there. And let's see. Oh yeah, so since we already have the option for set gain decibels, we can get rid of this juice decibels to gain. And we can just say tree state.get raw value gain. Too many brackets. So this is our gain in dB, right? It's just from the slider. So we can say, let me copy and paste it real quick. We can say gain module dot set gain decibels, and then I'll give it that tree state gain value, and we don't have to do the conversion anymore. And we can And we can do the same thing for, actually, no, we don't need to do it for phase because we're not using a DSP module for the phase. So we have this in prepare to play. Let's also do I normally also do that in set state? Yeah. Let's also do that in set state just to be safe. So we can get rid of this raw gain thing right here. Boom. And then remember one more place, we do it right here. So this is where the parameter is changed. Oh, good. I'm glad somebody is going to enjoy it. I honestly haven't been much into streamers, and I just kind of wanted to start, you know, just streaming what I do. If I do it all day anyway, I might as well stream it. I don't know if other people do any kind of programming streams, but I hope it's not boring. Where was I? Right, so this is the last place we need to move it, so I'm gonna say the same thing. Gain module.set gain decibels, but we don't need this tree state thing, right? Because we have this new value. So that's coming in anyway, so let's just use that. Nice. And look how much simpler this is gonna be. We have a process method that takes in a process context. So this is going to process the audio, and I'll show you how to actually do this. So I'm just going to put it right here. So gain module dot process, and it's asking for a process context. Now let's check that out. Process. Why is this not a link? All right, I'm going to have to type it in. Process context. Now, remember how I said that what you're doing with the buffer is you're not setting an input and output, you're replacing what's in the buffer with some kind of new value. So because of that, we're going to use the process context that's also replacing. So it's called process context replacing. And you can see that what was I about to say? Oh, you can see that it takes in an audio block. So it's inside of DSP process context replacing, and it wants a type, and I usually just use whatever type the module is set to, so like the gain module. And then here we need to pass it the block, and we give it an extra set of curly braces, and we'll just give it block, which is right here. And that should work. So now we're not having to do this loop ourselves. We're just having the process method do it for us. And let's see if that actually works. I think I'm on the latest Juice version. I might be one version behind, but I'm on either the latest or second to latest. I don't think there's been any major changes. I don't think I've had any breaking changes, but I did when I went from 5 to 6. I did, but I don't think we're on a major difference yet. Let's open what is that? That's Logic. Pull up our plugin. Look how beautiful that is. Oh, okay. And since we have that smooth, we set it to, what's it called? Set ramp duration seconds. So I should be able to do this wildly and not hear like pops and clicks. So that sounds fine to me. And then let's go back to the other route where we didn't have that. Or that's actually going to be annoying to do. Just trust me, the other way had pops and clicks. Yeah, so that's how easy it is to use the DSP module. Most of them are a simple process, and you process method, and you pass it a context replacing. So you always need an audio block, and you can put that in the process block right here. You're going to pass it a process context replacing, and then pass block into that context replacing. And that's really all you have to do for the process block. I usually, what I'll do is in the prepare to play, let me go to like the chorus one to make a different example. Chorus has a bunch of different parameters like set rate, set depth, set feedback. I would set all of those in the prepare to play with the tree state. And I would also do that in the set state right here, so that I know that whenever the plugin recalls, all the parameters will be correct. And every time prepare to play is called, the parameters will be correct, just in case. So yeah, that's what I do for that. And most of them, like the chorus one is just as easy. It just has more things to call. So these would just be different dials or sliders or whatever. Some of them are a little different. So convolution, you can create a convolution object, and then you have to load an impulse response. And these look a little scary. There's a bug flying around. But you can pass it. There's a load impulse response method where you can pass it a file. You could pass it this weird const void pointer source data, which just means binary data that's in the same folder. And you can also pass it a buffer if you wanted to. So this will probably be something that I do soon. Thinking about DSP tutorials that I want to do. So convolution is a little different. Delay line's also a little different. Let's see. Oversampling is a little different. You kind of set it to the oversampling factor that you want. So, you know, 2 times oversampling, 4 times, 8 times. You call init processing. There's no prepare method. You call init processing in the prepare to play method in your project. Then you process the samples up in the process block, do all your function calls, and then when you're done, process samples back down, and then you have your oversampling in plugin. Oh yeah, you're writing and using a utility function that wraps around a get raw parameter value. There already is another way to do it. I'm not doing it the most up-to-date way. There's it's like it's dot load. It's like maybe let me go look real quick. Oh, I know. We can go to GitHub. Let's go to the audio programmers GitHub and see if there is an example. Oh wait, I'm looking at repositories. Here we go. Okay, these are the ones that are pinned. I wonder, are these the most up to date? Let's see. Processor. Okay, so he adds the parameters just like I do. Chorus. Where does he do the parameters? Okay, I think this will be for any repeated function. Oh, you know what I do? Well, if it's a repeated function, wouldn't you still have to just call the new function you make every time? What I do is I have a stream deck and I have a page for Xcode, or I have a page for Juice. So I have a button that I press for a bunch of different code blocks that I would normally type. Like, let me show you real quick. Like this, this loop right here, watch this. I have a stream deck and I have a button for the block loop. And if I press it, it'll type the text. Just because I'll use that loop a bunch of times. I also have one for, oh, the attachment, using slider attachment, blah, 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 using dial attachment. I also have one for, oh, the prepare DSP that I put in the prepare to play method. So that's what I do. There might be a clever C++ thing to do, but I'm not sure. Let me clean that up. I want to see, there is a better way to do the tree state thing though. I think this is a pretty old project. I don't think he has it. It's gotta be the lay one. This one. That's gotta have it in it. Let's see here. Oh, look. So, oh, okay. So it's actually not much smaller. So mine's called tree state. He calls his params. So he's saying, for me, it would be tree state.get raw parameter value this, and then dot load. I'm not really sure what the dot load is for. Hold up. Let's see. Let's go into, what is it again? Audio processor value tree state. Yeah, code snippets. Yeah. You're talking about just making your own method that's just a shorter word to call than get raw parameter. Get raw parameter value. Oh, get low. Okay, so get raw parameter value gives you an atomic float. So that must be why he's using load. So like if we go back to, wait, that's C++. Okay, so let's do std atomic. Let's see, we've got, I don't want to use CPP reference. Where is, where's, oh, here we, damn, I was hoping there'd be a tutorials point one. Where is the, oh, here we go, member functions, load. Atomically obtains the value of the atomic object, as opposed to, I would assume that if it's an atomic type that it would already, okay, I didn't know that. Maybe I should just put that on all of my stuff. So if I go to here, load, indirection requires pointer operand. Okay, that works. Okay, so yeah, now it's loading atomically, which I guess is better because the attachment is on a different thread. The audio thread is on a different thread than the UI/message thread, whatever it is. So the attachment is connected between them. So it's probably better to do it atomically. Anyway, I can get rid of, can I get rid of raw gain? I'm gonna get rid of raw gain and see what happens. Build. indicate what implications it would have if it were done. Yes, precisely, but that's probably better done with JS. I mean, you could. Wait, let me make sure I'm following you. So you. Oh, you know what? The way I was thinking of doing it in my head, I don't think would work. Because, like, if I wanted to make my own method and say, like, get p for parameter, and it takes in, I don't know, a string called ID. I wouldn't be able to go and say get p. This should be float. That work? So wait a minute. Set gain decibels, get p gain, get p phase, phase, okay, I guess this works. Is this what you meant? So now I wrote the long way once, and then now I just have to write it like this? Is that what you meant? Let's see if this works in the DAW and recalls the parameters correctly. All right, so I'm gonna put the plugin in there. So let's put this down. Save, close. Oh yeah, look at that, it works. Wow, I never thought about doing that. Another thing you could do, take in a juice reference to the tree state, audio processor value tree state like this. And then that. And then that way you pass in tree state. Okay, that works. I don't know if it's necessary though, because are you gonna have more than one audio processor value tree state? I kind of doubt it. Okay, so that works. So yeah, I mean, I don't know if that's what you meant, but that's a little better. You know what I want to try to do? I want to try to do the online unlock form. I'm going to try to do that. It's on the Juice website under the tutorial page. Learn tutorial. Audio device manager class. Oh, this would be good to do for my guitar sim so that you could use it in standalone. I need to get to that one day. Plugins, plugin examples, DSP, graphics, interface. Utility. Collect app usage data from users in Juice applications. That would be cool. All right, let's try this. Unlock your plugins through online registration. The demo project shows a very simple UI with two buttons. One of them is used to unlock access to the other one through registration. When the unlock button is pressed, the registration form will open in order for the user to insert credentials. At the moment, the registration process will fail until we start implementing the back-end server. Okay, and this is what it looks like whenever it works. The Juice library provides a base class that acts as an interface called the online unlock status class. The first two steps towards implementing a store-specific marketplace is to inherit from the online unlock status class, and an example of how to implement this class is described in the Traction marketplace status. Since this implementation was designed specifically for a Traction marketplace, we need to create our own independent subclass. We will borrow code, blah, blah, blah. Insert a product ID for your application in the get product ID function and make sure this ID matches the product ID on the server later on. Okay. Okay. Yeah, this is more involved than I kind of wanted to do at the moment. I did have something else I was working on. Let's get rid of that and this. I was messing around with the juice progress bar. And before I go over this, it's a GUI app, it's not a plugin. So let me just press play and show you what it does. So it shows progress and then it stops. So what's happening is my progress is I am running a method. I've got 3 for loops inside of each other. And what I'm basically doing is, this is a simple check to see if the phase invert is on or off. So if phase is on, multiply by -1, and if it's off, multiply it by just 1. And the reason I'm doing this is I want to see if it's faster to use this if-else statement, or if it's faster to convert this into a mathematical expression. So instead of using this if-else, I'm saying signal is equal to phase times 2 minus 1, which gives you -1 or 1 without this if-else check. But I think the thing is, this is a bool, so it's still like checking. So what I'm doing is I've got 3 for loops inside of each other, each one doing either the phase condition, so the phase one, and then one doing the phase expression. And I'm seeing how long each one takes. So how long the if-else version takes, and how long the mathematical expression one takes. So I can change how many times it runs. So I have a run length of 500 for each loop. So what I'm doing is, if we watch the console, oh, I didn't hit the button. I have a button to start it. The phase condition took 1.1 seconds. The expression one took 1.14 seconds. And I'm getting how much faster the winner was. And while I'm doing this, I'm keeping a count of each for loop. So I'm saying current count plus plus. And that is being sent to the progress bar. So as those 3 for loops run, the progress bar counts up, and you can see when it's halfway, the first one is finished, and whenever it's all the way done, the last one is finished. So that's basically what I was doing. I wanted to check out the progress bar, and then I did something else. I made it multi-threaded. So this whole logic of doing this for loop check on the if-else and the mathematical expression is happening on a background thread that I create. So in the button, I'm starting a thread, and whenever the logic is done, you can see, can you see? Oh, right, here we go. Okay, so when you make a thread, it's a juice thread, and in the run method, you do what you want to do, and then whenever you're done with that, you tell the thread that it should exit because it's done. So what's happening is when I click the button, so on click for the button, you can ignore this current count. That's just, you know, helpful for reading the value, so whatever. But in terms of the thread, we're starting the thread on the button click. And the reason I did this is because if you don't make another thread, when you click the button, the count for loop thing will happen, and you won't be able to do anything else on the screen, and you can't use the button again because the button is still clicked down because this button on click isn't actually done yet. So by making a new thread, the button on click is able to continue execution down. So now the constructor is finished, and we'll set the size and will come up and stuff. So yeah, that's what doing the thread helps. And this is much easier in Juice because I was doing it with like the standard template. threading, and I was like, I wonder if Juice has like a thread class, and of course they do, and it's really easy to use. So you just create, it's kind of like Timer. It's an abstract class, so you don't create an instance of it. You just inherit from it, and you implement the override function. So for thread, that is run. For Timer, it's called timer callback. And I'm just putting whatever I want the thread to do in this run method, and then making sure that I exit the thread whenever it's done. I also exit the thread in the destructor just to make sure. Yeah, so that was actually not too difficult to implement. And let me show you what happens. Actually, can I do that? It'll be kind of a nightmare. What was happening before I went to another thread, you can see that on click happens, and oh wait, no, that was incorrect. I was right the first time. What would happen was the plugin would come up, I'd click the button, the functionality, that method would run, and it would take a few seconds, and in that few seconds while it's running, this on click method was still like active, so the button hadn't finished clicking, so you can't like do anything else with the button while it was running. So this, I mean, that's what threading is for. So that was pretty cool. I did that today. Oh, and let's run this a bunch of times and see if the if-else statement is faster than the expression or vice versa. So the expression was faster by 5%. The condition was faster by 7% that time. The condition was faster again by 6%. The condition was faster that time too. If we do this a bunch of times, you'll see that it's about half and half. Sometimes the expression will be faster. Look, expression was faster by 2%. So I guess the example is so trivial, and the difference between that mathematical expression and the if statement is negligible. But I bet if we put a bigger equation, the difference will be much higher. So let's go here. Okay, so let's do signal is equal to, let's do like a large polynomial. So like, I don't know, 10, or actually let's do this, std pal. So we'll raise 10 to I don't know, 10 plus let me also do this, 10 times that, then we'll do plus 20 times, oh, you know what, actually let's do this, 5, 10 minus 30. These are just random numbers. I'm just trying to create a more complicated and larger expression. Plus that let's do 3, 5, 7 and do 10. No. 2, 4, 6, 10, 20, 30. I don't know, just some random polynomial. That should be a large number, so... And actually, let's make this... Let's make each one multiplication, or at least let's make it addition so that it's larger. And that, well, that's the only place that happens. Okay, so let's test that and see if it's any slower. Oh yeah, look how much slower that is. Wow. That polynomial took 20 seconds to complete. That just shows you how expensive DSP can be. Okay, so let's do something even smaller. So signal times equals phase at least, or actually plus equals, no, times equals phase plus 1 times 100. Not even, or let's say plus 100 times 1,000. Not even that big of a difference. Not even a complicated equation. So the first half of the progress bar should be the if else one, and the second half of the progress bar should be the signal times equals phase plus 100 times 1,000. Okay, let's do it. Okay, so that wasn't bad. That was pretty negligible. So let's do phase plus 1,000, or let's just do phase plus 2 raised to 100. Oh wow, look at that slowdown. Oh, it wasn't as slow as the first time, but slower. So 2 raised to 10. Yeah, it obviously slows down even though it's not that much slower. It's about the same. So, wow, look how slow just a simple mathematical expression is compared to this if else. I don't know if this is obviously just me messing around. I don't know if this is the best example or use case, but what I do know is that if else, so if phase signal times equals -1, else signal times equals 1 is the same thing as signal times equals phase times 2 minus 1. That is the same thing. The same stack allocations are happening. So these variables right here. So that should be the same thing pretty much. This is equivalent to this. And there's really not much of a difference. Okay, so it's very negligible and it's also doesn't take that long. So let's make it take longer. I bet the more and more loops and the slower and slower it gets, I bet more of a difference and maybe one will pop out. So let's do it like 1024. Okay, so got this. Let's engage it. Oh, I messed up. I forgot. One thing I have to do is, you see this right here? This is how I'm getting the percentage of like 0 to 1 in terms of progress. So I had to figure out what 3 for loops nested inside of each other, what the total was. And I think whenever I type in 1,000, the total is 200, 200, 2,000. And there's probably a much better way to do this, but this is just what I did while I was prototyping. So let me change this to 1,000 and see if that works. Okay, so that looks like it might work. Okay, so the first half of the progress bar, which is all happening on a background thread, and we know it's on a background thread because look, the button is still touchable and reacts. Okay, so the conditional was 5% faster, which I don't know, isn't that negligible. Let's do it again and see if it's consistent. Because I have a feeling that at really quick, small loop sizes, it's running so fast that it doesn't really matter. It's going to be different every time. But I bet the longer it takes, the more of a consistent result we'll get. Oh, maybe not. Look, the conditional version was faster by 1% as opposed to 5%, which is kind of a big difference between two different runs. The conditional version was faster by 0.3%. It's slowly approaching the expression being faster. So maybe this logic is still so simple that the difference is like negligible, even when doing it a bunch of times. The conditional version was faster by 2%. Yeah, I wonder. I mean, I'm sure this test case is flawed. I was just messing around, but yeah, I don't know. But it was cool. I'm glad I figured out how to do multi-threading with Juice. I don't know if this stream or what I just went through is going to be good enough for a video to pull from. I might have to do a or just like remake it live maybe. Yeah. And this is this is a lot of code that's kind of dumb. But yeah. I'm not really sure what I don't really have a use case for threads on the UI, so like I don't know. Anybody in chat have any questions? Something I could go over that you'd be interested in? Because I don't know what to work on next. I see you lurking. I see four viewers. Oh, I should put this thread example in a repo. I don't know. I should make a video about it. Okay, let's see. What else do I have? I haven't really done much for the guitar amp idea. It would probably be good to revisit some older projects. We could work on more UI stuff. Oh, let's pull up the intro. Okay, that's this one. Okay, let me build it real quick. Okay, there we go. So, first of all, I want to take the background color from this progress bar test. Let's see here, this right here. fill all. Just put this here. Okay, let's see what that looks like by itself. The color is way more pleasing. Yeah, it's a cool color. The dial looks stupid against this color, but the background color itself looks really cool. Let me show you how to use my Viator DSP library. I don't remember, did I pull it into the Producer? So here's the Producer for the Stream Juice Intro project. If I go to modules, no, I didn't. Okay, so you need Juice DSP because my DSP module relies on the Juice DSP module. So if you hit click, add a module, or actually add a module from a specific folder, you can clone my Viator DSP repo. Click on the folder and click on the modules folder, and that will be what gets loaded in right here. So it's pretty easy to use. So let me take, for example, Slider. You can go to my docs page. Where is it at? landonviator.github.io/viatordsp-docs. So here's the README. This is the same README from the GitHub repo. And then you could go into something like the GUI classes and you could look at dial. And this is what my dial looks like by default. It doesn't have a default constructor, so you have to pass in the required parameters. So the text value suffix, the range, and the return value. So I'll do that real quick. So instead of juice slider dial, we'll say Viator GUI, and it's called dial. Okay. And it doesn't have a default constructor, so we have to come up here. And I'll just go to the next line right here, and I'll say dial. It will auto complete the things that it needs. So I'll type in a text value suffix. I'll call this dB. We'll say range start negative. This is a gain utility, so we can go all the way down to like 60, and then up to like 24, I guess. The interval value, the value between each is 0.01. That's good enough. And then return to 0 on double click. And we can get rid of this stuff. All you need is the attachment, if that's what you're doing. All you really need to call is add and make visible and set bounds. Oh yeah, don't need a init dial, not using that. And then we can build and we see what the default dial looks like. Wow, it's taking forever to build. Oh yeah, it takes forever for it to index through those modules. And here we go. Here's the dial. It has this cool little feature where when you mouse over it, it highlights slightly. It's got a nice little shadow going around it. It's got a pleasing color. The font is bold. And it is, what's the font? I think is it Helvetica, I think. And it has a couple of different styles. So if you go back to the docs, there is set dial style. So it's got a couple of dial styles called hard dial, full dial, alpha dial, and able dial. Let's make sure they actually all work. So right here we would say dial dot set dial style. So you would go into the Viator GUI dial style, and then whatever you want. Let's do the alpha dial. And then one thing you also have to do if you change the dial style, you have to call this method called force shadow. It was just something that I figured out. The shadow was not being flipped back on after you set the dial style, and I have no idea why, but this fixes it. So for right now, we're gonna go with that. This is what the alpha dial looks like. It's just a little different. It's not too much. It's not too crazy. But there's the Able dial, which is kind of like an Ableton style dial. Oh, I must have messed it up. It must not work. Let's come back to that. Let's go to full dial, which is the cool one. Yeah. So this one needs to be a little bit bigger to look nicer. I mean, this is okay, but you know, it looks a little weird, the size of it. Yeah, so that's the full dial. I think that one looks really cool. And we could also, so this is a group component going around here. There's also a group component in the Viator GUI. So where's it at? Right here. Okay. Viator GUI, I think is it called border? Is that what I called it? Border. Okay. Let's see what happens whenever I just hit run. Yeah, I just need to move it, but yeah, it looks cool. The border is thicker, and the text is the same font as the label for the dial, and the font is bold and larger, so it's a little easier to see, a little more pleasing. There's also a label, so Viator GUI label. And speaking of that, we can go into the label. We can take out this justification because that's already handled in label. Order, yep, that should be good. And the label should have the same font as the rest of the stuff. Yeah, it does. It's just in the way. So let's get let's fix that somehow. Should the plugin just be bigger? Yeah, it's 300 by 300 right now. So let's make it, I don't know, 600 by 600. And then we can go into this init window. Whatever. Yeah, okay, that's a lot bigger. Okay, so that's cool. Oh, and everything is yeah, that looks okay. I'm gonna widen the border a little bit. So let's see, how did I do that? I got border. Okay, so X position, Y position, the width. Oh, the width is dial size. Okay. So you know what? I'm gonna set this. I'm gonna set the border. and then add that to the width and see if that is correct. Okay, so it needs to be wider. So plus get width, I guess double. No, times. For some reason I want to say 8. No, it's way too big. Okay, that's close enough. Oh, you know what? To make it mathematically correct, something that would be easier is to use, instead of trying to set the sample, the pixel, we can do get local bounds, size keeping center, and then new width. We could say, dial size is get width times 6.4. So maybe 81. Okay, so it needs to be much larger. So let's just say 9.5. Yeah. And the last thing, we can change the button to the Viator button. So Viator GUI, it's called push button, and we can get rid of the stuff that we set up for the button. Set clicking toggle state is already set for us, and the colors are already set for us by the Viator GUI module, so we should just click and it should just look good. Yeah, look at that. That looks okay. Although the text doesn't look quite right. Why does the button text look not correct? Because if I go to button on the docs, push button. Oh no, that's correct. Okay, that's fine. Maybe I want to change. I think I want to change the alpha. Okay, hold up. Let's go into the module. Widget push button. Oh, good. I didn't have the oh, here we go. It's black dot bar. So let's do with alpha. And let's do 0.5. See what that looks like. A little too dark. I think it might need to be something more like 8.5. That's better, I think. Cool. 0 is right there. Oh, and then our range is wrong because even though we set the range right here at -60 to 24 in the audio parameters, in the tree state, it's still, yeah, -24 to 24. So if we hit 60, cool. Starting at 0, that's what it looks like. And yeah. So there you go. That's how easy it is to use my GUI module. And I definitely would like to add some stuff to it. So as I go, I will add things to it and add to the docs. And yeah, that's our plugin. I think it looks pretty nice. Nice little utility plugin. Let me go ahead and push that, and you can download it and do whatever you want with it. Okay, and then I also made some changes to, let's see, updated button text alpha. And that's it. Cool. I think that's all I have for today. I'm not sure what I should do on Friday. I'll be back on Friday at 5:30 Central Standard Time. What should I do? Could start. We have all of the GUI stuff, so we have all of the basic GUI. I could start doing some DSP concepts. Yeah, I mean, I definitely would love some suggestions. Also, code crackers. Check out our Discord. I have 2 Discord links in the on the Twitch page. So we have 2 communities: the Viator DSP community and one community called the Audio Visual community. So they're both pretty much dedicated to anything audio. So like music production, composition, synthesis, sound design, music, gaming, coding, juice, software development. I mean, anything. We'd like to focus on audio and stuff like that, but you know, we're gonna hang out and have a good time. So, you know, as topics arise that people are into, we'll make more channels. But we do have a bunch of channels already for you to hang out in. So yeah, go check it out. All right, I think that's gonna do it for me. Thanks for watching. See you next time.